Okay, welcome to the video on energetics, and we'll do a brief bit of theory, and then you can do stuff because there's so much lag on the computer these days that when I write for too long, it gets worse and worse and worse. So this topic is energetics. Okay, and it's very simply, there's two types of interaction in chemistry: endothermic and exothermic. Just the two pretty well. All right. So endothermic is when energy goes into the system. Energy into the system. All right. Exothermic is when energy comes out of the system. I'm sure we all knew that. All right, if it goes into the system, it must come from somewhere, and it comes from the surroundings. So in this case, when it goes into the system, it comes from the surroundings, and therefore the surroundings will get cooler. If it goes into, if it leaves the system, it goes somewhere, and it goes into the surroundings. And if it does that, the surroundings get hotter. That is essential, all right? So if it's an endothermic reaction, the system gains energy. That's why delta H is positive. If delta H is positive, the surroundings lose, and they get cooler. And for an exothermic process, the system loses energy, so that's negative. But the surroundings gain the energy, so surroundings gain. Surroundings gain. Okay, so a very simple diagram. Let's do HI. That's a nice one to do. Let's do this. I2 plus H2 gives me 2HI. Nice simple reaction. I think, for the life of me, I can't remember. I think this is exothermic, but I might be wrong. It's not really important. Okay, so what's actually happens here? Well, we have an I molecule, an iodine molecule, I should say, and a hydrogen molecule, and we get two HI molecules. Now, the only way we can break these up, or what we have to do for the molecule to form the products, is we have to break up these guys. So I have to break these bonds. Okay, and then I have to make these bonds. Okay, now breaking bonds is endothermic. In other words, we have to put energy in. So this process, we have to put energy in, and when I break them, that's not good, is it? When I break them, I'll get I and an I and an H and an H, and then I form the products, and I'll get HI, HI. So energy in other words, breaking the bonds is endothermic, and making the bonds, energy comes out here. Energy out, and that's called exothermic. Okay, so there you go. That's what's happening when we have a reaction. We have to break the bonds initially, and then we have to reform the new bonds. So let's put that in an energy diagram. If we put this in an energy diagram, it will look something like this. We'll have a line there and a line there. You'll have your reactants here, which are I2 and H2. You'll have your products here, which is 2HI, and the reaction will be something like this. Go up, and it will go down. This distance here, whoops, this distance is the end. Oh, that's awful, isn't that? this distance here is the energy I've got to put in, often known as the activation energy. And this distance going down is the energy that comes out. So this part is endothermic, and this part is exothermic. All right, the difference between the two, in this case, it's this distance. The difference between the energy you put in, the energy you get out, is called delta H. And as you can see, in this case, delta H is negative. So that means the exothermic part, this part, is bigger than this part. That's why it's exothermic, because more energy is given out than taken in. How would we say that? Excuse me. How would we say that? We might say it something like that, like this. The reaction is exothermic because the energy taken in for bond breaking is greater than the energy released in bond making. That's an excellent answer. I would copy that down. So there you go. So what we've got there is we've got an overall exothermic reaction because the energy in is less than the energy out. Okay, so now I think that's enough of me talking. I'm going to copy this and I'm going to paste that there and see if you can do that problem. Okay, actually, to be honest with you, I'll do the first one and then you do subsequent ones. All right, so I'll show you how to do this. This is from a past paper. Bond energy is the amount in energy in kilojoules which must be supplied to break 1 mole of the bond. Use data in the table to show the formation. So the following reaction is exothermic. All right, now I'm going to break all the bonds. Okay, all right, what bonds do I have to break? I have to break CH bonds. I have to break CC bonds, and I have to break C double bond C, and I have to break HH bonds. They're the bonds I have to break. Okay, according to the table, the CH bonds, to break those, the lag has started. To break the CH bond is going to cost me 415. To break a CC, according to the table, is going to cost me 346. To break a CC is going to cost me 610. And to break an HH is going to cost me 436. Okay, according to the table. How many CH bonds do I have to break though? Let's count. 1, 2, 3, 4, 5, 6. So I have to break 6 of those. How many CCs? There's only one CC. There it is. So that's it. How many C double bond Cs? There's only one of those as well. So all of the energy required to break the bonds is 6 of those, 1 of those, 1 of those, and 1 of those, according to this equation. Now this means there's 6 of those. Okay, now and then we add all of these numbers together. That's how much it's going to cost me to break all of the bonds. So it's 6 times 415 plus 346 plus 610 plus 436. So to break all of the bonds, it cost me 3882. And the energy had to go in because we're breaking these bonds. Breaking bonds. That's the energy that went in. Energy in is this. Okay, so what's energy out then? Let's form the bonds. Forming bonds. Okay, Now I've got CH's there, CH, and I've got CC's. That's all I've got. CH's and CC's. How many CH's are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of these. How many CC's are there? There's 1, 2. So therefore, how many, or what do I get out here? All right. So CH is 415. CC is 346. But I need 2 of these, and I need 8 of these. So that equals what? Let's see. 8 times 415 equals that, plus 2 times 346. I get 4012. These are kilojoules, by the way. That's the energy that I get out. Now, out energy is exothermic, so we're going to put that as a minus. And this is the energy out. Whoops, there you go. That's the energy out. So I put this energy in, and I got this energy out. So overall then, delta H must be the energy I put in, which is 3882, minus the energy I got out, which is 4012. So here we go, 4012, 3882. I get minus 130 kilojoules per mole. And that's what it wanted. Show that the reaction is exothermic. And I have shown that because I have shown delta H is negative. Is that clear to all of you? Are we good there? Yes, no, maybe? You can use these things or these things. Are we good? Is anyone there? Is everyone gone? All right, what is it, Medisa? You can put the microphone on. Bond making is always exothermic, yes, always. And bond breaking is always endothermic. Are you good? Everyone else good? Give me a thumbs up. Medisa's good. Anyone else? Tabang, Tada, Abiella. Are you just turning on? All right, Abiella's good. Tabang, you there? Tada. Because I'm going to give you one to do on your own now. Okay, so try do this one. All right, Medisa, if you get this one, I'll be very impressed, okay? That one. Do that one then. I'm going to have a rest. You can probably hear my voice is a bit croaky today. All right, so do that one for me. Okay, and we'll see what answer you get. I'll give you 5 minutes for that. I'll play some music while you're doing that. Has anyone got an answer yet? Thumbs up, thumbs down. Anyone have an answer yet? Not yet. Okay, I'll give you some more minutes then. Hurry up, guys. We haven't got all day. I'm coming home now, right away. I'm coming home, baby, now. I'm sorry now I ever went away. Every night and day I go and say, I'm coming home, baby, now. Coming home, baby, now. I'm coming home now, real soon. Coming home, baby, now. I'm coming home, I know I'm home. Since you went away, real soon. I'm coming home, coming home, baby, now. I'm praying every night. Everything is gonna be fine. Coming home, baby, now. I want to be you tight. Like to see me now, I wait in time. And I'm in your arms, I'm coming home. I'm coming home, baby, now. I'm coming home now, yeah, yeah, yeah. I'm coming home, baby, now. I'm coming home, if you remember what I said. I'm coming home. Yo! Hold on! Oh, Moultrie. Yes, go for it. What is it? Excellent, yeah. And I need a number. 19. Let's go. All right, turn your microphone off. I'll do it. Abiella Medisa, did you get an answer? Did you get minus 19? Minus 113. Abiella, anything? All right, so let's quickly do it then. One of these should be right. Let's go. All right, energy in. I've got to break CH bonds. I've got to break CC bonds. And I've got to break a CLCL bond. Okay, a CH bond is going to cost me 412. A CC bond is going to cost me 348. And a CCL bond is going to cost me 242. All right, how many CHs are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of these. Oh, the lagging is awful. Again, I have no idea why. 2 CC bonds. So there's 2 in there. Oops, I'll mix that later. and there's one ClCl. Okay, so the energy in should be this. 8 times 412 equals that, plus 2 times 348, plus 242. I get the energy in is 4, 2, 3, 4. That's endothermic, because that's the energy in. That's what I get. Now, the energy out, I've got to do CH bonds again, CC bonds again, and an HCl bond this time. How many CHs are there? 1, 2, 3, 4, 5, 6, 7. So in this case, there are 7 CHs, and that's 4, 1, 2, plus how many CCs? 1, 2 CCs. All right, so it's 2 times, where's CC? 3, 4, 8. Okay, and now I've got to do an HCl as well. HCl is 431. 431. So I get 7 times 412 equals that, plus 2 times 348 equals that, plus 431 equals that. I get 4011. It's exothermic, so it's there. So delta H is equal to that number plus 44. Oops, I've messed it up. Hold on. 4234 minus 4011. I get endothermic 223. Can you see? Maybe look, it's very possible I made a mistake. But can you see? Did I make a mistake there? Anyone? Can you see? Can you see where you made mistakes? We good. Yeah. Did I make a mistake? Okay, cool. Where did I make it? This one. Oh yeah, I didn't, did I? This one here. Didn't I add this? Yeah, oh, bond making. Where's the CCl? Oh, you're right. Good, good. Well done. Excellent. I didn't see that. Good for you. CCl is 338. So I have to add 338 here. 338. Okay. Well done. Well spotted. Oh, go away, stupid thing. Right, this thing here. So I have to get rid of this, even though it's lagging again, guys. All right. So well done. Well spotted. All right, this is what makes these things hard. They're not hard, they're just awkward. Plus 2 times 348 plus 431 plus 338. And I get now minus, because it's an exothermic, 4349. Add these two numbers together. 4, 2, 3, 4. I get 115 now. I get minus 115, which is close. Look, this possibly, Medisa looks, maybe I've made a mistake here with something, but this one looks the closest to mine. As me. Good for you. All right. Tabang, do you see where you went wrong? All right. Abieli, do you understand it? Oh, well, there you go. All right. So the energy that went in is 4234. The energy that came out was 4349. So the difference is 115. Okay, I'm going to write that in an energy diagram to show you how it fits with energy diagrams. Okay, so look at that. Not like that, I'm not. You see, the lagging is so awful, I can't even delete things. Okay, so if you were asked to draw an energy diagram of this, it would be this. There, and there, and you would go up, and you would go down, even though it's not very pretty. The energy you would have to put in there is 4, 2, 3, 4, and that's endothermic. The energy you get out, all of this energy you get out, is 4, 3, 4, 9, which is exothermic. And that means the energy difference, the delta H, is minus 115. Does that make sense now, Abiela, where these numbers come from? No? Yes? Good, well done. All right, let's do another one. Guys, you did very well, though. You know what? There's no gain without failure, I promise you. It's always the way. You've got to try your best, and that's the only way you get good at these. So try this one. For 3 marks, they give a lot of marks for these things. They really do. Okay, I'm just messing around with the page here to make it all nice. There. So have a go at that one, and I'm making tea. So I'm gonna give you 2 minutes, and I'll be back. Okay. You only want me when you're lonely. You only want me then. You only need me when you're lonesome. It's then and only then. You only want me when you're crying. You only want me then. You only miss me when you're blue, dear. It's then and only then. But someday you might too late in time. You need my love. You'll come home, but I won't be there. Oh, you only want me when you're lonely. You only want me then. You only need me when you're lonesome, but I'll be gone by then. Are we done? Thumbs up, thumbs down. Not yet. Okay, no problem. Back to the music. Tabang, what's the question? What's the question, Tabang? Yeah. If you look at that, how many I bonds are you breaking? How many Cl-Cl bonds? How many ICl bonds are you making? Oh, how many ICl bonds are you making? 2. Could you see, Tabang? 2 ICl. All right, off back to work.